In my demonstration here, what I'd like to do now is use Wireshark and Telnet to help us create and test these access control lists. The example I want to use is the one we just did here, and I have already written the access control list for us, and I've made a copy of it in my clipboard, and we're just going to paste that onto router B and apply it in the outbound direction. But before we do that, what I'd like to do is verify that the information in this is correct. And what I'd like to do actually is start from workstation 172.1930.96, which is the IP address I've given to my workstation right here, right now, and the one I'm going to be doing the demonstration from. So we're going to use that as the baseline. And before we actually apply that access list in the outbound direction, we're going to test each one of these systems and look at the output in Wireshark to see if our packets match the way that our access control list is written. So you'll definitely want to take a screenshot of this so that you have this up and running while I'm walking through the demonstration, so we have some baseline to know what we're talking about. Now, in my demonstration drawing here, I do have networks shown for 10.10.00 and 10.20.00, and I do not actually have those configured on my router. I don't have another Ethernet interface to use, so those are just pretend for now so that we can have our access list running here. They're not necessary for this lab at all, so we can just pretend that those exist, but we're not actually going to use them as this part of the demonstration. If you're trying to set something like this up at home, what I've done there on the server side is I have a Linux server set up. It's just an Ubuntu virtual machine, and I've installed the OpenSSH product on it. I have a web server there. That's just actually a Windows workstation. I've also used a Linux workstation for that. Windows is pretty easy for that. You just is a matter of clicking and turning it on in Windows. And then the DNS server there, what I'm actually using there is I've hooked up one of my routers. And I've used the configuration I gave you in the application layer course on the router to get it configured as a DNS relay. And that's actually what I've done now. I've just used that router as my DNS server as a quick, easy way to set up DNS services. Now, I'm not doing any kind of routing on that router. It's only acting as a DNS server relay. So I'm going to leave this behind. We're going to move on to other pieces of the configuration. I have the base configurations on router A and B, and I can SSH into each of them. And additionally, I'm using OSPF as my routing protocol to get the routes from router A to router B, and that way I don't have to use my static routes. So let's go apply this to router B. And then before we actually apply it to the interface, we're going to start testing from 172.1930.96 with Wireshark first, and then we'll apply the access control list second. While that information is fresh on my clipboard, I'm going to SSH to 10.0.0.10, which is router B's interface F00. We'll log in. I think I typed my password wrong. There we go. Go to privilege mode and config mode, and then I'm just going to paste that access control list that I built. So I just right click in PuTTY and it pastes it for me. And this is the same access control list that we extracted using that table that I have you set up to take the story problem that I gave you, convert it into the requirements, and then we can take those requirements in the table and convert it into our access control list. So we'll leave that sit for now. What I'd like to do next is verify that every operation works here. So let's open up Wireshark, and I'm going to start up Wireshark and start capturing, and then we're going to do the experiments that we need to do. So we can just leave this run in the background. I'm going to open up Google Chrome, and we're going to do a brand new incognito browser, Control-Shift-N, and we'll go to the website 192.168.42.80, and that should pull up our website. There we go. This is some demonstration text to verify the web server at 192.168.42.80 is operational. Excellent. So let's close that window out. Next, we're going to build an SSH session to 192.168.42.22, and there we go. Log in there. Password here is password. This is my Linux server. If I do ifconfig, we'll see that this is the IP address of my Linux server there. We can exit out of this. And then the last one we want to do here is an NS lookup. And I've already configured my DNS server on this workstation to point to 192.168.42.53. And I have a couple names in there like DNS. So the DNS server is named DNS, and it gives back an address of the 192.168.42.53. If I do a DNS lookup for web server, there I get 192.168.42.88. And SSH server, we get my 192.168.42.22. So we know DNS is working as well. So let's now go back. We can close this window and stop my Wireshark capture. And now what I'll do is we captured a lot of stuff in here. I'm not too concerned about it because we can use this filter to select just the traffic we're looking for. So let's start off with our web traffic by just doing HTTP. So I do that, and here we go. We have 172.19.30.96, which is my workstation, sending a GET request to my HTTP server. Well, if I right-click on this and do a follow TCP stream, what we're going to get is we'll get the website that was transferred here in my text document, but that's not what I'm interested in. What I'm interested in is this message right here, this first message, which is our SYN message coming from my workstation going to the web server. If we examine our header information now, we look at the source IP address, and it is my workstation. The destination IP address is the web server. My source port is 52.234, and my destination port is 80. So right here, if I want to figure out how to write an access control list to filter traffic to the web server coming from my workstation, right here is all of the information we need, right? We have a source address, a destination address, a source port, and a destination port. Remember, the source port is going to change over time, and it's not always going to be the same exact number. So we have no idea what that is going to be, but we do know whenever we go to that web server, we're going to have a destination port of 80. So if we're ever confused about what the source and destination IP addresses are to get to a web server when we're trying to write an access control list, we can do this simple experiment and just try to use the service that you're trying to filter, capture the traffic in Wireshark, select the packet that's coming from your workstation going to the server you're trying to get to, and now you can see each one of the pieces of the puzzle there that you need. Let's do this again. This time we'll do it with the second service we tested here, which was SSH. So I'll just type SSH in there. And we do have a couple SSH sessions happening. One of those SSH sessions is going to the router, except we should be able to see that pretty clearly. So if I look, here is a message coming from my workstation going to 192.168.42.22. That is my server over there. If I once again right-click and do follow TCP stream, that is going to show us all the traffic that we've sent with SSH. However, really what I'm interested in again is that SYN message, the first part of our three-way handshake. Here we can see our source IP address, so 172.19.30.96, destination IP, 192.168.42.22. Source port again, this is that unusually random port number, the ephemeral port number, 52,235, and then our destination port of SSH on port 22. Once again, here's all of the pieces of the information we need in order to write an access control list to permit traffic from 172.19.30.96 to my SSH server on my server network. Last, let's take a look at DNS. Since I do have a DNS server configured on my workstation to go use, my workstation is going to constantly be querying that DNS server. If I scroll to the end of the list here of my capture, I should see the NS lookups that I did earlier. And if I open up a DNS here and look at queries, that's looking for Office. That's my workstation. Let's try this one. Another one looking for Microsoft. Oh, here we go. Here is an SSH server. This is my query for the SSH server. And then here is the DNS server replying, saying that the SSH server is at IP address. Well, looks like this is not actually the SSH server I was looking for. This is actually looking for an IPv6 address for the SSH server, and the reason I know that is the type is AAAA, which is an IPv6 address. If it was just type A, that would be a IPv4. So we have something else going on there. Let's try this other one. Here we go, type A. So here's my request coming from my workstation to the DNS server. Notice that we're using user datagram protocol to do that. The source port is 62,267. Destination port is that of DNS on port 53. And here my query is saying, hey, what's the IP address for this device named SSH server? And then the very next message I get back comes back from the server saying, well, here's your answer. And the answer is 192.168.42.22. So we can use this once again, my source and destination IP addresses, plus now it's actually showing me my transport layer protocol of UDP, then my source and destination port numbers here. So using Wireshark on my workstation that's sending traffic, we can send the traffic that we're trying to filter, use Wireshark then to capture the source and destination IP addresses, source and destination port numbers. Now, be very, very, very aware that routers will never, ever, 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 ever change the source and destination IP and the source and destination port numbers. Now, I'm kind of telling a fib about that, but for the time being, at this point in the course, this is exactly the fact. We have never talked about a case where the router modifies the IP address in the header. We have never talked about a case yet where the router modifies the source or destination port numbers of the segment header. We're going to talk about that exact behavior in the very next course called network address translation. But network address translation is a very special case, and we have to explicitly configure the router to do something with the source and destination IP addresses if the administrator decides to do such a thing. So we only modify those source and destination IP addresses when and only when the administrator configures it. At any other case, we should expect that the router is not modifying our packet headers IP addresses or the segment headers port numbers. And because of that, we should be able to use Wireshark to build very nice, clean, neat access control lists.